Welcome back, friends. In the previous session, we have seen energy signal and power signal and neither energy nor power signals. So in that, we have seen how to determine a signal, whether it is an energy signal, power signal or neither energy nor power signal by simply observing the graph, means observing the waveform. We have to say these things. So in that, we have seen neither energy nor power signal means all unbounded signals. All unbounded signals are neither energy nor power signals. Next, in the energy signals, we are having two kinds of. What is that? One is a finite duration, finite amplitude signals. All are nothing but energy signals. Next, if it is an infinite duration signal, then we have to observe that its amplitude has to tending to 0 at a t is equal to minus infinity and t is equal to plus infinity. These are the things we have to see. Next, power signals. In the power signals, we told that power signal means it must be infinite duration. It must be infinite duration. In that, we are having again two categories. All periodic signals are definitely a power signal. Next, suppose if it is an infinite duration signal which is not periodic, then its amplitude has to be a constant value at t is equal to infinity or t is equal to minus infinity. These are the things what we have observed yesterday. Let's take some examples so that you can say whether what kind of signal it is. Okay, let's see. Example. Let's say r of t minus r of t minus 3. By observing this r, that means ramp function, so many people think that it is going to be neither energy nor power signal, but it is not the way. First, we have to observe what is the waveform. We know how to draw this waveform with respect to t. Let's say up to 0, its slope is equal to 0. After that, it is going to be increase, and after that, slope is equal to 0. This is the signal actually, because it is having two corner points. One is 0, another one is 3. At 0, the slope introduced is 1, so it is going to be slope 1 line. And at 3, it is introducing minus 1. So for 1, if I introduce minus 1 slope, final slope will become 0. So it will reach a maximum value 3. So by observing this waveform, so you have to tell me what kind of signal it is. It is nothing but a power signal. Why? Because it is an infinite duration signal and its amplitude is tending to a constant value, which is nothing but 3 in this case. So I can say yes, it is a power signal. Power signal. Next, suppose next example, u of t plus u of t minus 2, t minus 2. Again, we have to draw the waveform to determine what kind of signal it is. It is having two discontinuity points. One is 0, another one is 2. So up to 0, its amplitude is 0. After that, it is going to be 1. So at 2, its amplitude is going to be 2. So this is the waveform 1, 2. Now if you observe this, again it is an infinite duration signal whose amplitude is going to be constant at t tends to infinity. So again it is going to be a power signal. Again it is a power signal. Next, if I take another example, 2 plus e power minus 60 u of t. We have to see what kind of signal it is. Is it an energy signal or power signal? So I told you, first we have to draw the waveform, then only it is visible for us what kind of signal it is. So I am trying to draw this. If you observe carefully, this is nothing but combination of two waveforms, which is nothing but 2 u of t plus e power minus 60 u of t. These are the two waveforms which are combined together to get this waveform, final waveform. Now let's see. 2 u of t added with e power minus 60 u of t. 2 u of t. How this signal look like? From 0 onwards, its value is going to be 2 plus e power minus 60 u of t. How this signal looks like? it is exponentially decaying function like this, whose value is 1. Understood? If I add these two signals, the resultant signal, how it look like? The resultant signal, how it look like? See, up to 0, both the signal values are 0. So 0 plus 0 is equal to 0. After 0, this signal is added with some constant 2. Then what will happen? This signal is shifted upwards by 2 units. Then it looks like this. So this 0 value will go to a new value which is nothing but 2. And it is starting from 3. So 3 it is decreasing, but it is not reaching 0 in this case. It is reaching 2. Finally, this value is going to be 2. Now, if you observe carefully, it is an infinite duration signal whose amplitude is tending to 2, which is a constant value at t tends to infinity. Then this comes under the category of power signal. Okay, take it. Power signal. Please make the notes. We will see some more examples. Suppose in this example, if it is asked, suppose 2 plus e power minus 6t, that's it. There is no u of t, then how it look like? Again, it is a sum of two functions, one is 2, another one is e power minus 6t. So many people think that again it is going to be similar kind of thing and it is a power signal. No, it is not the power signal. Why it is not a power signal? You can understand easily. Let's see. 2. How it look like 2? This is the 2. Next, e power minus 60. See, e power minus 60 is a exponentially decaying function. It is existing from minus infinity to plus infinity. So it looks like this. Okay. So this is the one. Now if you add them, then the resultant signal looks like this. The signal is shifted upwards by 2 units, then 2, it is decreasing like this. It is decreasing. So if you observe carefully, this signal, whatever we have drawn here, is unbounded function. Why? At t tends to minus infinity, this value goes to infinity, which is a unbounded signal. Unbounded. If it is a unbounded, the signal is nothing but neither energy nor power signal. Neither energy nor power signal it is. Okay, take it. Next, suppose if I take another example, t square u of t. So if I draw the signal, which is nothing but parabolic signal, again it is going to be unbounded function. It looks like this, parabolic function. It is again unbounded. Whenever the signal is unbounded, no doubt it is going to be neither energy nor power signal. Neither energy nor power signal. Let's see one question from your workbook which is given in the previous GATE examination. Question number 18. Which of the following is not power signal? Which of the following is not a power signal? Not a power signal. Options are given. Step. Option B, e power j omega naught n. Option C, ramp. Option D, periodic. Periodic. So if you observe carefully, everything, step function we already decided it is a power signal. E power j omega naught n is also power signal because it is a periodic, and it is periodic signal, again it is a power signal. Only the thing is ramp signal. So this ramp signal, which is nothing but unbounded, which is a neither energy nor power signal. So the answer is option C. This ramp signal is like this, which is keep on increasing, unbounded. So it is a neither energy nor power signal. Okay, take it. Let me read this question. A real signal x of t have 3 joules on its even part and 7 joules on its odd part, then total energy of x of t is dash joules. Okay, so they said a signal x of t having even part, and in that even part the energy is equal to 3 joules. 3 joules. And energy in the odd part is 7 joules. 7 joules. Then what is the energy in the x of t? What is the energy in the x of t signal? That's the question. Okay. First of all, we have to understand x of t is neither even nor odd signal. If x of t is neither even nor odd signal, then only we can write x of t is a combination of even part and odd part. Even part plus odd part. To write this, first of all, x of t has to be neither even nor odd signal. Okay. They said even part having 3 joules, odd part is having 7 joules. So many people think that 3 plus 7, which is nothing but 10 joules. But unfortunately, whatever you are thinking is correct. 3 plus 7, which is nothing but 10 joules, which is a correct answer only. But the procedure what you are thinking is a wrong procedure. So let's see how we can say 3 plus 7, which is nothing but the total energy of the signal x of t. But it is not the case in all every signal. That means, let's say, if a signal x1 of t and x2 of t having these two energies, then can you tell me x1 plus x2 is having how much is the energy? Then it is not equal to 3 plus 7, 3 plus 8. But in this case, in this particular case, yes, that is going to be true. How it is going to be? Let's say, if I try to find out energy of x of t, the formula what we have to use is integral minus infinity to infinity x of t square dt. I am not considering the modulus here because it is a real signal. Now I am substituting x of t is equal to x even part of t plus x odd part of t whole square dt. Now I am just applying the a plus b whole square formula. Then it is going to be integral minus infinity to infinity x even part of t square dt plus integral minus infinity to infinity x odd part of t square plus 2 into dt dt plus 2 into integral minus infinity to infinity x even part of t x odd part of t dt. I just applied a plus b whole square formula, nothing else. I haven't done anything else. Now try to understand. I am suddenly saying this value is equal to 0. How can I say that? This value, this integral value is equal to 0. How can we say this value is equal to 0? Is there any reason behind this? First try to understand. If I take a even signal multiplied with an odd signal, the result is odd signal. We know this. And integration of minus infinity to infinity odd signal is 0. On that basis, even signal multiplied with odd signal, the resultant is a odd signal, and the integration over symmetrical limits is 0. So finally, we are going to get this expression. In this expression, this integral indicates energy of even part. This integral indicates energy of odd part. So I can say simply, this is nothing but energy of x even part of t plus energy of x odd part of t, which is 3 plus 7, that is 10 joules. So from here onwards, remember this. X of t, energy of x of t is equal to energy of even part plus energy of odd part. That's what it is. Okay. Remember this and take it. If energy of x of t, let's say capital E, then what is the energy of x of at? X of at, that is the question. Okay. Now directly I am going. Energy of x of at, the general formula is integral minus infinity to infinity x of at whole square dt. That's it. X of at whole square dt. Now here let at is equal to m, then dt is equal to dm by a, and if t value is equal to minus infinity, that implies m value is equal to minus infinity if a is positive. T value is equal to plus infinity, then m value is also equal to plus infinity. Now I can rewrite this integral as integral minus infinity to infinity x of m square dm by a, dm by a. So if we take a common out from the integration, 1 by a integral minus infinity to infinity x of m square dm. Now we know this integral. See, here the only variable is changing. Suppose if I write x of t square dm, it doesn't matter if you write x of m square dm, because only the variable is changing. So if variable is changing, the integral value does not change. So still this is going to be the energy divided by a. In general, you can remember, in general, energy of x of at is nothing but E by mod A. So even though if A is positive or negative, it doesn't matter. We will always take E by mod A is the energy. Okay, take it. Of a signal is P if power of x of t is equal to P, then what is power of x of at? That's the question. How much? Okay. Actually, power of x of t means, it is usually, the notation is limit t tends to infinity 1 by 2t integral minus t to plus t x of t square dt. That is actually power of a signal x of t. Okay. Then they want to find out what is the power of x of at. So let's see. Power of x of at is equal to limit t tends to infinity 1 by 2t integral minus t to plus t x of at square dt. X of at square dt. Now let at is equal to m and dt is equal to dm by a. dm by a. If t is equal to minus t, that implies m is equal to minus at. If t is equal to plus t, that implies m is equal to at. m is equal to at. Okay. Once we got this, now let's go with the formula. Limit t tends to infinity 1 by 2t integral minus at plus at x of m square dm by a. dm by a. Now if I take a outside the integration, then it is going to be integral, limit t tends to infinity, limit t tends to infinity 1 by 2at integral minus at plus at x of m whole square dm. Now what is this integration and this limits indicates? It is nothing but p only. This is and that one both are same. How, sir? You can understand. We are doing the integration from minus at to plus t. That means how much duration we are considering, which is nothing but 2at duration we are considering, and we are dividing with 2at. So finally this is going to be average power t tends to infinity. So directly that is nothing but the p only. If you don't believe it, let's take, let's say at is equal to some tau. Let at is equal to some tau. Now t tends to infinity, then tau tends to infinity. So this integral can be written as limit tau tends to infinity 1 by 2 tau integral minus tau plus tau x of m whole square dm. So both the integrals are exactly same. Both the integrals are exactly same. There is no change in it. Only this m is got changed. That means there it is t, here it is m. It won't make any difference. Both are exactly same. So I can say this is nothing but p only. So from here onwards, remember power of x of at is the same as p, which is nothing but power of x of t. Okay, take it. Let's say energy signal. If energy of x of t is E, then what is the energy of, first please try to understand this, x of minus t. That means energy of x of t, if it is E, what is the energy of x of minus t? Means what is the energy of time reversed version? Means what if the energy value, what is the energy value if you fold the signal? It won't make any change. It is going to be the same value, which is nothing but E. This is the one. Next, energy of x of t minus t naught. This is also E because time shifting also does not change energy of the signal. Next, energy of x of at. This is what we know. Just now we came to know that E by mod A. Now, energy of x of at plus b. This is also E by mod A. E by mod A. How, sir? Because I told you time shifting does not change the energy, only scaling will change the energy. Okay, that's why. Next, energy of Ax of t. Energy of Ax of t. So, if I multiply a signal with some constant A, then what will happen to its energy? So, if you try to find out the energy of the signal, we have to square the signal. Then it is going to be A square x of t square. If you take A square out of the integration, then A square of the energy, which is nothing but A square E. A square E. So, this is about the energy signal. In the similar manner, if I go with the power signal, if power of x of t is p, then what is the power of x of minus t? Power of x of minus t, which is also same as p. Power of x of t minus t naught, that is also p. Power of x of at, that is also p. So time reversal, time shifting, time scaling, nothing is going to change the power because we are always calculating the average power. So I can say everything is same. So here power of x of at plus b, this is also time shifting, time scaling, both does not change the p. But this one, power of Ax of t, this will definitely changes the power. So which is nothing but a square p. A square p. Only amplitude scaling will change the power of the signal. Nothing will change the power of the signal. Okay, take it. That means, let's say, suppose if energy of x of t is equal to E, what is the energy of x of 2t? From this formula, which is nothing but E by 2. Next, energy of x of t by 2, which is 2E. 2E. Now, observe carefully. X of 2t, which is nothing but time compression. If time compression is there, definitely that will reduce the energy of the signal. Next, coming to this one, x of t by 2. So it is nothing but time expansion of the signal. What is it is doing with the energy? It is actually increasing the energy. So I can simply write time compression. Time compression. Energy decreases. Energy decreases. Time expansion, energy increases. Energy increases. Okay, take it from your workbook. Question number 20. Question number 20. What the question is saying that the waveform x of t is as shown below. How this x of t looks like. So this is the wave they have given, which is a periodic signal. Okay. X of t. If x of t is as shown in figure, and if g of t is equal to x of t minus 1 by 2, t minus 1 by 2, then average power of g of t is, then average power of g of t. So they have given x of t, they want to calculate what is the average power of g of t. Okay. First try to understand. To find average power of g of t, which is nothing but average power of x of t minus 1 by 2. Now, so many people think that first we have to find x of t minus 1 by 2. From that we have to calculate the power. But it is not the way. Actually, I just told you x of at plus b having a power which is same as x of t power. So, time scaling, time shifting does not change the power of the signal. So, I can say whatever is the power of g of t you want to calculate, which is same as power of x of t minus 1 by 2, which is same as power of x of t, which is same as power of x of t. So if we try to find out the power of x of t, which is same as power of x of t minus 1 by 2, so it won't make any difference. Now, because it is a periodic signal, we know what is the power formula, which is power of x of t is equal to, for periodic signal, x RMS square, which is nothing but 1 by t integration over a period x of t square dt. This is the formula what we have to use. Now, let's say, first and foremost thing, what is the period of the signal? So many people think that it is 2. No, it is actually 3. It is 3. Why, sir? If you see, after how much time it is going to be repeated? If you take the 0 point, after 3. If you take minus 1, it is after 2. So minus 1 to 2, if I take minus 1 to 2. This is nothing but period. This is nothing but period of the signal. Now, let's see. I can divide this integral into two parts, that is minus 1 to 1 and 1 to 2. Because minus 1 to 1, we are having a single function which is a straight line passing through origin with a negative slope, and 1 to 2, the value is 0. So I can say 1 by 3 integral minus 1 to 1. What is the function? If you observe carefully, it is nothing but y is equal to mx. Y is equal to mx line. That means we have to find out the slope of the line, which is changing from 3 to minus 3. That means change in y-axis is nothing but minus 3 units, and change in x-axis is nothing but 2 units. Minus 6 by 2, which is nothing but minus 3. So minus 3t whole square dt. This is the expression for the signal x of t between minus 1 and plus 1. Plus 1 to 2, it is 0 square dt. So if you could solve this, 1 by 3 integral minus 1 to 1 9 t square dt. So it is going to be 3, suppose if I multiply with 9, minus 1 to, sorry, this is t cube by 3. The limits are from minus 1 to 1. So 3 get cancelled, finally t cube, which is nothing but 1 minus of minus 1, which is 2 watts. The power of the signal is 2 watts. Understood? Take it. Now, some examples. X of n is equal to 1 by 2 whole power n u of n. First of all, we have to understand what kind of signal it is. Is it neither energy nor power signal? No, because it is a decaying exponential, because 1 by 2 whole power n, mod a value is less than 1, so it is a decaying exponential. So it is definitely not the neither energy nor power signal, and it is energy signal because its amplitude is tending to 0 when n value is tending to infinity. Okay, so it is a energy signal. Then how to calculate the energy of a discrete time signal? Energy signal. Then energy of x of n is equal to summation n is equal to minus infinity to infinity x of n square. So because the signal is having u of n, I have to take only the limits 0 to infinity. N is equal to 0 to infinity. If I square it, 1 by 2 whole square, that is 1 by 4 whole power n. So if I try to find out energy, so here let's see, you know the summation, which is nothing but 1 by 1 minus a, which is nothing but 1 by 1 minus 4. So it is nothing but 4 by 3. That is the answer, energy of the signal x of n. Okay. If I give in the same way, what is energy of x of n is equal to 3 power n u of n. First of all, energy is infinity, power is also infinity. Why, sir? Because it is neither energy nor power signal. How can we say it is a neither energy nor power signal? Because it is growing exponential and it is going to be unbounded function. So it is an unbounded signal. So because of this, it is neither energy nor power. Neither energy nor power. Next. Next question. X of n is equal to a e power j pi by 2 n. So because it is a periodic signal, the method is directly, whether it is a periodic signal or not, n is equal to, I can say 2 pi by 2 into m. So it is 4 into m value has to be 1, so it is nothing but 4. So it is a periodic signal. The method 1 directly, power is equal to x RMS square, which is a square. Directly there is a formula. Let's say method 2, that x RMS value can be found, p is equal to 1 by n summation n is equal to 0 to n minus 1 x of n square, mod x of n square. Why we have to take mod x of n here instead of only x of n? Because it is a complex signal, modulus is mandatory. Now if I try to find out this, let's say 1 by 4 summation n is equal to 0 to 3 x of n, which is nothing but, what is the modulus of x of n? Which is mod a e power j pi by 2 n, which is nothing but a. So a square. So I can say a square by 4. We have to write 1 for 4 times, which is 4 get cancelled. Finally this is also a square. In this way we can calculate it. Understood? Take it. Next, suppose if x of n is equal to 6, 4, 2, 2. Arrow is here. Now what kind of signal it is? Is it an energy signal or power signal? Definitely energy signal. How can we say this is? It is a finite duration signal because it is having finite number of samples. So it is a finite duration signal, and it's a finite amplitude signal because its amplitude is never going to be infinity. So finite duration, finite amplitude. So definitely it is an energy signal. Now try to find out energy of x of n. Find energy of, first question, x of n. Second question, x of 2n. Third question, x of n by 2. For these signals we have to calculate the energy. Okay, Directly, energy formula, which is nothing but summation x of n square. Summation x of n square. That means we have to square and sum 6 square, 4 square, 2 square plus 2 square, which is nothing but 60. Now, x of 2n, how much is the energy? So many people think that it is going to have energy of 30 joules and x of n2 is having 120 joules, which is absolutely wrong. Why? Simply, let's see. Whatever the formulas we know in the energy case, which are applicable only for continuous time case, but not for the discrete time case. Discrete time case, we cannot use those formulas like E by mod A like that. We cannot use that. Why, sir? You can understand. First, can you find out x of 2n? That means keep the 0th position as it is and pick every second sample. So it is going to be 6, 2. For this energy, then we have to simply square sum 6 square plus 2 square, which is nothing but 40, which is not 30 joules. I hope you understood. Next, x of n by 2, we have to insert 1 0 between the samples. 0, 4, 0, 2, 0, 2. So because we are adding only zeros, it won't make any difference. So if you try to find out energy, which is nothing but 6 square plus 0 square, 4 square, 0 square, 2 square, 2 square, plus 0 square plus 2 square. So it won't make any difference. So I can get again 60 only. So this is what you have to remember. Okay, take it.